Hey guys, today we'll just be working on another program in C. We're going to be using the external keyword. So in the last external keyword video, we went over external in one file, so this one's going to go over external in two files. So it's going to show the use, how you can use it between multiple files. And so hopefully you guys will understand how to do that. So we'll start with we'll start in the second file. So I've created a second file, so not in the main file. I just called it alt. What did I call it actually? I think I called it. Okay, let me just remake that. I'm not sure what I did. So I'm just gonna right click my main.c folder, click on C/C++ source file. I'll just call it alt. That's it. Change the type to .c. Hit OK. Hopefully this works. So then we'll start here. So here we'll call extern. Int buf array. Okay, so I think it's red. So maybe that's just because it's not in main, so that's okay. So we'll just go with that for now. So we have an array named buf, buf. Then we'll have an int pointer. So remember, a pointer is also an array. It can be treated like an array. It basically is an array. So we'll have buf, pointer buf. So pointer buf p0 points to the location of buf of array index 0. Now we're going to go over external, we'll go over static too. So static makes something private, pretty much. It's the opposite of Java, so pretty much external is static. So in Java, static pretty much is like external in C. External lets you use the same variables or functions. Well, I think functions are default external already, but the variables, you can use them pretty much in any file. It works like static pretty much, but in C, static makes it pretty much private. So it's completely the complete opposite of Java for some reason. Not sure why, but that's just what it is. So it makes it like local, and it makes it like a private local. So we'll go static int here. Pointer buf p. Then we'll have a void swap. So that's going to be a global no semicolon. So that's just going to be a global variable. So we'll have a global function. It's pretty much just a function that's in a secondary file. So here we'll have int tmp, so just a temp int. So we'll call buf p1, which is member static. So it's pretty much private, so we'll call buf p1 here. Points to the location of buf of array index 1. Okay, so buff p1 points to the location of buff of array index 1. So we have buff p1, that's our static, so pretty much our local. Let's just say that's our private local. That's global. Okay, yeah, so the buff int buff p0 is global. The static's like a private local. Actually, no, it's not a local. Buff p1. Okay, it's pretty much local. It's a private local. It's pretty. Let's just say it's static, which means it's private for now. I'm taking this from a book, so I'm not sure if they're exactly correct on this, but I'll just assume they are. So at least we know that it's static. This one. We know that that one's static, so that's okay. It's not necessarily defined in a function, so I'm not sure if it's 100% local. Perhaps it's local to the file, so that's maybe that's what they mean. So we have okay, so we have void swap, that's global, a global function, or it's a secondary in a secondary file. Then we have a temp. This is a local for sure. So let's just go with this. This is how I remember it. So we'll just say this is local. That's a private. Up above is a private. That's a local below. So then now we have so above p1, which is so we're referencing our static variable points to the location of our global. Actually, no, our external. So we're referencing our external location of array index 1. So we're referencing this one. Buff of array index 1. So we're saying, okay, well, buff p1 points to that index, the address of index 1, or location of index 1. Then here we'll say temp points to pointer value buff p0. Here we'll have pointer value buff p0. So it's a little confusing with these names because they're all similar. So we'll have buff p0 points to pointer value buff p1. Then we'll have pointer value buff p1 points to temp. So we're swapping. We've done a swap before. This is like in 2 files. So buff p1 points to temp. So what's exactly happening? We have our external int buff array at the top. Okay, so we have our temp local here. Here we said we're referencing our external variable to point to the location of. Actually, no, my bad. So we have our static variable, our static buff p1, which is going to point to the address of our external address of buff of array index 1. So maybe I should just write that out. So we have static. So static buff p1. Actually, maybe. Okay, let's not write it out because I'm going to write the same thing. So it's just going to say. So it's going to be this. It's the static buff p1, which points to the address of. Actually, maybe I could write that out. So we have static buff p1 points to the address of external buff of array index 1. Not static, my bad. Okay, so the next one we have a temp, a local temps pointing to our okay, so we have, there's going to be a chain here, so it could be, might take a little bit to understand. So we have pretty much a bunch of links probably. So we have our buff, so we have our static buff p1 pointing to the address of our external buff of array index 1, so that's buff p1. Now we're calling buff p0, which we haven't called yet, but that's pointing to buff, because we're saying int pointer buff p0 points to address of buff 0. Buff p0. So now temp points to buff p0, which is pointing to pretty much the address of buff of array index 0, which is our external. So what's happening here is we have like a triple link here. So we have our, okay, so it's local temp. So local temp variable points to pointer value. Actually, no, okay, I apologize. So this is pointer value. So don't get confused here. Actually, yeah, okay, yeah, so don't get confused. It's not pointing to buff p0. It's pointing to the pointer value. So whatever the value of buff p0, not the address. So it's not a triple link. Actually, kind of it is. So we have buff p0. What's the value of buff p0? So buff p0 is pointing to the address of buff of array index 0. So it might be null in this case because we have nothing. Because above here, above we have buff p0, pointer buff p0 points to address of buff of array index 0. Then we go up. What's buff of array index 0? Well, it's pretty much empty right now, so it's probably null at this point. So we'll check it in the debugger in a sec. So points to pointer value of buff p0, which points to, so it is a triple link, which points to buff, so which points to the address of buff of array index 0, which is probably null. Because there's no values at this point, so it should be null. Unless it's going to store a garbage value, so it might not be, it might just be pointing to a garbage value. So we'll check. So then we have buff p0. So pointer value, buff p0 points to pointer value buff p1. Which again should be, okay, so sometimes this can get tricky because you're changing it again. Whoops. So pointer value buff p0 points to, that's the thing about C is like if you're so far into a pointer, like it's hard to manage where everything is pointing to unless you run it through the debugger. So if we have a pointer buff p0 pointing to, I guess that's anything, but like even because you can't see globals in C with the GCC compiler, it doesn't keep track of global variables in the debugger, so that pretty much makes it difficult. You can't check the links of a global, so that pretty much makes you lose everything. If you're trying to manually read it, you can't really track it that well. So if we have our pointer value buff p0 pointing to buff p1, pointer value buff p1, so buff. So pointer value buff p0 is currently pointing to the address of buff of array index 0. So now we're changing it to point to the address, to the value of buff p1. So pointer value buff p0 points to pointer value buff p1. So buff p1 is, so let's just say static, and should be also empty. Actually no. Buff p1 is pointing to address of buff of array index 1. So pointer value buff p0 was pointing to address of buff of array index 0. So we had pointer value buff p0 now point to pointer value of buff p1. So here we had buff p1 pointing to address of buff of array index 1. So now we're saying, because before we had, actually we didn't call this before, so we had pointer value buff p0. Actually we did above. We had it above here. I think it's pointing to the same spot. See, look here, because originally we had this buff pointer value buff p0 pointing to address of buff of array index 0. Now we're pointing pointer value buff p0 to point to pointer value buff p1. Well, pointer value buff p1 points address of buff of array index 1. So pretty much beside this of what it already was. So it's moved over an index pretty much. So pointer value buff p0 points to pointer value static buff p1, which points to address of buff what was it? Make this smaller actually. So pointer, okay, so which points to address of buff p1. The buff p1 points to the address of buff 1. Address, okay, so yeah, so buff of array index 1. So it's moved over an index, I think, by 1, shifted to the right by 1. If you're looking at an array going right. If you're looking at an array going down, it moved down an index. So now we have pointer value buff p1 points to temp. And it's saying temp points to the pointer value of buff p0. And buff p0 points to the address of buff p1. So it's a little confusing. But the goal of this is just to understand external and static, because we've probably done enough pointers at this point to help you guys understand. Like, it's a good amount of pointer practice that we've done so far. So we have pointer value buff p1 points to temp. Yeah, that's pretty much all we really need. And then in our main file, we'll just have include stdio.h. We might need that actually in this file too. So we'll have that. Include stdio.h. Okay, then we'll just have some. I don't think we use this, but we'll just include it. So we'll have an int buff array index 2 points to 1, 2. Then we'll just have our int main here. we'll call swap. What's wrong with that? Great, it's not catching the other file. I think I didn't set it up properly, so what is wrong here? C98, C99. So how we did external is that how we use external is that we have our external definition with extern. Okay, yeah, so that's why we have buff. So the reason why we have buff is because we have external int buff here, and here we're defining it again. So it pretty much lets us use it in the other file too. It's kind of like a backwards kind of thing. But for some reason, I think it's it's catching it there. See? Is it giving? See these? I'm not sure if you can see those arrows, but it says go to related global variable. So it's saying, okay, well we define an external an integer array named buff, and we're saying, okay, we want it to be external so we can use it somewhere else. So this means look for this definition outside the scope. So here's the definition, and in swap it calls buff. So you may have to play around with it if you're actually coding something and you're not sure how to use it. You can just switch it. So if you're confused and you don't know how to use it, just make an int buff array and then put external here, external int buff array of index 2, and if it doesn't work, just play around with it. So just switch them back and forth until you get the desired result. That's pretty much what I do just to see how it works properly. That's probably the best way to learn, so you know what's wrong and what's right and how to use it. So just if you're not sure about external, just play around with it. That's the best way. Okay, so the problem is here it's not catching the file. Maybe because it needs a prototype. There's no parameters, so prototypes go. We'll just put it here. So we'll say swap. Is it void? Void swap. Okay. Void swap. I spelled it wrong. There we go. Catching it now? Okay, there we go. Hopefully that works. So we did have to prototype it. In my notes, there's no prototype, so my professor was on something when they wrote this code. Okay, so let's test it now. So we'll just put a breakpoint here. Hopefully it works properly. So yeah, so we'll just click the debug icon. Hopefully it catches it in the debugger, because already global. It will actually. I don't think it will, to be honest, completely, because it won't show globals. So that's going to be hard, unless the external catches it and helps us show that buff is, yeah, it's not even showing buff. So we have temp pointing to, we have temp, so we have buff p1 points to address of buff1. Yeah, this isn't going to do anything here, because that's the thing with C, is that it doesn't show globals in the debugger. The GNU GCC compiler doesn't keep track of it. Reason being is like, I'm not 100% sure, but whatever's stored in the, so when we have a stack and a heap for like machine code. So when we have our heap, it basically stores the variables. It stores the variables for certain globals and locals and stuff. So what the problem is that it's not catching. Either way, they didn't want to basically provide the data, so it's just missing the data for us. It's pretty much just not showing it. It's not like other languages will show you globals in the debugger, right? Like other object-oriented languages, maybe even other languages like JavaScript and stuff. It shows you the globals, Python, Java, but in C, it doesn't. So this debugging is useless, because look, we don't have anything to look at. It just says temp points to int 0. If you step in here, nothing, no change. Now we're saying, okay, well, temp points to int 1. Points to int 1. Nothing, no change. But either way, you guys, this is, so hopefully this, at least this video helped you guys understand how to use external, so we just define it in another class. Or sorry, not a class, in another source file. And then we define it, or like, we define the variable that we want to use. In this case, it's an int array. We tag the external modifier before it. And we're saying, okay, well, in this code, we're using a buff array, and the values are currently undefined. So we're saying, okay, well, we want to fill that buff array later on. And we're going to say, okay, well, we want to externally include the data in another file. So we're going to use external here, which makes it global, but external lets us access another file. So we're going to say, okay, we'll access another file, so we're going to define our external variable here. We're going to say it's a buff array of two elements with two integers, so 1 and 2. So we're saying, okay, well, in our swap function, we have now a buff array that we're accessing from another file, which is passing into this external array. So it's now sharing the data in both files, and we're getting the 1 and 2 from the other file, and we're saying that it's indexed at 2 elements. So now we can say, okay, well, address of buff array of index 0 is going to be the address of 1. Then the address of buff array of index 1 is going to be the address of 2. So it's going to fill the data in from the other file. So like I said, if you guys don't understand, just play with the external variable, the keyword, put a buff array here and put an external here, and then just switch them around till you get the desired effect, and that'll help you guys understand. And the other point of this video is to understand static. It just means that it's private. So we're saying, okay, well, static is private to this file in this case. And we don't want the scope of static to be referenced from another file. So we've made it private. We want to make it unaccessible, so we can privatize it to make the file more secure. So that's the point. So hopefully that helps. Hopefully that helps you guys, and you guys understand static and external more. We'll be working on some more examples. We're gonna finish off with macros, of just a few examples of macros, because they're kind of tricky. And then we'll do dynamic memory allocation. We'll do a malloc, calloc, and a free example, and that should be concluding the whole C tutorials. So hope you guys like the videos. If you guys like the channel, you guys can like the video and subscribe for more videos. And I'll see you guys next time. Take care.